Is this the homework?
Everyone like hid their faces. Can everyone just say hi for like a second? Yeah, we're gonna do the homework. Everybody get on, say hi, and then
Hi.
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 Hello.
where you are. Let me see where you are. Maverick, welcome. Megan,
Thank you.
Hi, Miss.
hi, sweet girl. Everybody, I was gonna wait one more minute. We'll start at 3:15, if that's okay. Do you guys have any questions before we get started? Okay, so quick pulse check. How many of you are done with the video?
I'm done. Can't you like raise your hand in here?
Anthony, you finished?
Yeah, I finished.
Megan?
Me too, Miss.
Maverick?
Yes.
Okay. Miss Nyoko? Okay, so it looks like we're all good with the video. Then is it okay if I skip over the ones that we did there?
Oh, I didn't do anything.
Ah, I found you out. All right. We're going to just do one problem that I did in the video because you should have watched that, and then the rest will do the leftovers. Let's get started with number 1. So remember, we're finding here, we're solving for angles. The question is, what angle if you find sine? An answer of 0. So I'm starting by labeling it. Well, I know 0 is going to be y over r. I'll always put it over 1. You can put it over anything. You can put it over 5, over 6, it doesn't matter. But we like to use 1. And then we're asking ourselves, okay, guys, is this a triangle or an axis angle? Can we have a triangle whose leg is length 0? Does that exist? I'm waiting to hear from you. Estudiantes, ¿dónde están? Where'd you all go?
No.
So yeah, Maverick, feel free to jump in since everybody else already watched this part. But I can't have a triangle with a side length of 0. So this has to be one of my axis angles. And if you haven't written this down in your notes, do it now. Over here we have 1, 0. 0, 1.
Is this notes or homework? I'm sorry.
I'm doing a little bit of notes for you, but you should have watched the notes. So what I'm doing right now in the first like 3 minutes is a little bit of notes.
Okay.
While we're doing the homework at the same time. So take a screenshot if you're like hurrying to copy. When we have an axis angle, it's going to be either here at 0 degrees, at pi over 2, at pi, or down here at 3 pi over 2, or at 2 pi. And those are our options. So now I'm thinking sine is y over r. Y has to be 0, so where is y equal to 0? Is it equal to 0 on the x-axis? On the x-axis? Or is y equal to 0 on the y-axis? Where is y equal to 0? So Maverick, what's the y value up here? At 90?
0?
The y.
No, it's 1.
It's 1. So that's not what we're looking for. We want to know where y is equal to 0. So that's going to happen over here on the right and on the left. So that'll be at 0 degrees and at 180 degrees. And those are our answers, 0 and pi. So you'll notice for these questions that you can have 1 answer, 2 answers, and then we'll see one where you have no answers, no solution.
Okay.
Cool. So let's do number 2. Number 2 was a homework problem. Who can start us off? Step 1, let's label our formula. Go ahead and shout it out so we can move faster. Sine is?
Y over R.
Y over R. And this is positive. So R is always positive. That means Y is going to be positive. Okay, which 2 quadrants is Y positive in?
Quadrant 1, quadrant 2.
1 and 2. So I'm going to drop the perpendicular. I'm labeling y as positive 1 on both. And my r is equal to 2. Okay. Who remembers what kind of triangle has a 1 and a 2?
30, 60, 90.
That's right, 30, 60, 90. So remember, Maverick, write these down. 30, 60, 90 is 1 radical 3, 2. And 45, 45, 90 was 1, 1 radical 2. So don't be confused about the radical. We have a 1 and a 2. We're dealing with a 30, 60, 90. So, Tazzy, what goes across the 1 here and here? It's the reference angle on both.
45.
Say that louder.
45.
Careful, we're dealing with a 30, 60, 90.
My bad. You said on the 1?
Yeah,
30.
30. There you go. We got 30 here and 30 here. Guys, we are one step away from finishing this problem. What's our first answer? Hint, it's this angle.
30.
Who can tell me what math to do to find my second answer? Hint, it's this angle measured from 0 all the way over.
Subtract 180.
180 minus 30 will leave me with this angle, which is 150 degrees. Questions here before I move on? Stop.
Can you like?
So when we're in this, let me quickly review something we did 2 weeks ago. Guys, write this down in your notes. If your reference angle is in quadrant 1, that's your answer. And I'm doing stuff in this box. If your reference angle is in quadrant 2, then you're going to do 180 minus the reference angle to get your answer. Because you're not quite as big as 180, you're a little bit less, so you're going to subtract. If you need to go all the way to quadrant 3, you'll do 180 plus the reference angle to get your answer. If I have a 30-degree reference angle here, my angle is 180 plus 30, it'll be 210 to get that big angle. And then finally, if you're in quadrant 4, what math would we do?
360 minus the reference angle.
Nice, 360 minus the reference angle to get our answer. Okay, we did 1, we did 2. We just need to put our answers in radians. So 30 degrees, remember 30 is pi over 6, the opposite of what it sounds like. So if 30 is pi over 6, what's 150 degrees going to be?
5 pi over 6.
Tazzy, how'd you get 5 pi over 6? Good.
I use, well, I kind of
Can you speak a little bit louder?
divided 30 by 150.
Perfect. You know that it has to be a pi over 6 because this guy's a pi over 6. They'll always match. And then you're thinking, okay, 30 times what gives me 150? Well, you need a 5, and we're done. Okay, you tell me, did we do 3 in the video or no?
Did we do what?
Did we do number 3 in the video or should we do it now?
I think we did in the video.
Okay. So I'm going to skip 3 then. What about 4? Let me check.
Ellos lo van a poner por medio de los estudiantes. Ellos te van a mandar el Wi-Fi para la computadora.
Okay. So I'm going to give you guys 2 minutes to try one problem. I don't think I did number. Oh, yeah, I did 3. I didn't do 4. So let's do that. Let's do number 4. Okay. So take a minute and set up number 4 as best as you can. When you're ready, turn your video on, show me your work, and I'll just nod yes or no. And in 2 minutes, we'll go over it. If you finish.
Internet para estudiantes. Y ahí te va a aparecer la información, porque es la que han promovido ahorita, que tienen que tener internet para los estudiantes, como al mismo Entonces ellos se encargan de dar el internet para Ajá. Y si acaso hay que pagar, fijarlo de que están en el libro que vamos a dar.
Okay.
We do number 4, right?
Yeah, we're doing number 4.
This is hard.
Number 4 has only one answer, just so you guys know.
Oh, I think I. Okay.
Maverick, how did you start the problem?
I wrote it down
And then?
and I drew a graph.
Okay, so first step, you should label, write this down, your variables x, y, and r. Which variables are we using with cosine?
X and R.
X over r. I'm missing a denominator, so I'll put this over. One, right? Okay. So far, I haven't done anything clever. I just know the formula. That's it. So now I have to ask myself, okay, Maverick, and anybody else who is like struggling, is this a triangle or an axis angle? Think about y and x as the legs of a triangle, and r is the hypotenuse, right?
Yes.
Can you draw me a triangle whose hypotenuse is the same length as the leg?
No.
That's not a triangle. That literally is not the definition, right? A triangle, the hypotenuse has to be the biggest side. So this is not a triangle. So if you went and started graphing, you're gonna run into some problems really quickly if you started like drawing triangles. Not a triangle, this is an axis angle. So Maverick, tell me something that you notice about this, about our signs here. Because we're looking at the positives and negatives to try to decide where to go.
You're gonna go to the 90 degrees.
Up here?
Yeah. Because it's a positive one.
It's a positive one on the X or on the Y?
On the X.
Which way is the
No,
X?
so then it's gonna be on the what is it? The 0?
That's right. It's gonna be at 0 degrees, exactly. Way to correct. So up here would be a positive one for the Y value. So we wanna be careful. If I have a positive X value, I'm gonna go over here. Now question, you guys, I'm gonna make a mistake. Tell me what's my error. X is also equal to 1 at 180. What's the problem?
Negative.
It's -1. And I can't have a negative X because that would change the problem. So actually, we only have one answer here. What's that angle over there?
0.
0 radians, 0 degrees. Any questions on how we figured that one out?
No.
Let's do 5. All right, number 5. Cosine, same as before. Guys, call out for me. What's my cosine formula?
X over R.
And are we dealing with a triangle here or an axis angle?
Triangle.
How did you know it was a triangle?
Because you have the 1 and the square root 2.
Which kind of triangle has a 1 and a square root 2? Very good.
45, 45, 90.
Beautiful. 45, 45, 90. That's a 1, 1 radical 2. So figure out what quadrants you're going to be in. Hint, there's 2 that work. Okay, so where are our x's negative? On top, on the bottom, on the left, or on the right? I want negative x values.
You have negative x on the left.
On the left, on both of the quadrants on the left. So draw one here, one here. Drop the perpendicular. See if you can do the next step yourself, which is just to label the sides. So does that negative belong with the 1 or with the radical 2? Maverick, this is a question for you. Does that negative belong with the 1 or does it belong with the radical 2?
With the 1.
How do you know? You're correct. How do you know that? Who can help?
Because R always has to be positive.
Beautiful. R is always positive. That's like,
Oh, I didn't even hear.
oh, that was, yeah, I was asking you, how did you know? So we know it's got to be with the x because R is positive. So let's label our x as -1. Our R is radical 2. And that means that our y, what are we labeling our y, our up and down side?
1.
1. And this guy's -1. Great. Now we're interested in this angle here so we can answer. So what's our reference angle going to be across from the 1? What should our reference angle be across from the 1?
Me?
45.
45. Sometimes I'm just asking questions to everybody, so whoever answers. Yeah, well, we have 45, 45, 90. That's the 45 side. Now let's answer the question. My first angle. Pop quiz. Miss Tazzy, what math are we doing for this angle? For my first answer. 180 minus or 180 plus?
Wait, which one are we on?
This angle right here. I'm trying to figure out what this is. So what math are we going to do?
180 plus the reference angle.
Did you say 180 plus?
Yeah, 180 plus the reference angle.
Won't 180 plus take me further than 180? It'll give me a bigger angle?
Oh, minus.
Yes, 180 minus 45, but you're not wrong. The next angle is 180 plus.
Mm-hmm.
Let's do both at the same time. The first one's 135, the second one's 225, and now let's answer in radians. Do you guys remember pi over 4 is 45?
Mm-hmm.
No.
Okay, so pi over 4 is 45. So remember
It
this.
is?
Yeah, I'm reminding you now. So this is pi over 4, 45. This guy's 3 pi over 4. This guy's 5 pi over 4. I recommend that you write this down. And this guy's 7 pi over 4, which is 315. Do you remember that pattern? We would do like a stupid little dance. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And it goes all odds around the circle. So what two angles are we dealing with here? What's this guy in my second quadrant? That'll be 3 pi over 4. And my other answer is?
5 pi over 4?
That's right. 5 pi over 4. And you don't need to memorize it. All you need to know is 1, 3, 5, 7. That's the pattern that we use for 45-degree reference angles. 1 pi over 4, 3 pi over 4, 5 pi over 4, and so on. You guys, we're done. We finished that problem. So I did number 6 in the video. I did number 7 in the video. Let's just talk quickly about the difference between the two. If you're done, if you already did both, go to number 8. If you didn't, hang out with me for a second. So who did not yet do 6 and 7 besides Maverick? Okay, it's just me and you. Hey.
Hmm?
I said, hi, it's just me and you doing these. So look at number 6, Maverick, and I'm just chatting with you right now.
Oh.
Start the problem, labeling your sides. We can do it together. What should we label?
I didn't hear anything.
Let's start the problem together.
Oh, okay.
What should we label here?
That's x over r.
Nice. And what do we notice? Triangle or axis angle?
That is same as before, right? It's a axis angle.
Axis angle, exactly. We can't have a leg that's the same as the hypotenuse, just doesn't work out. So now narrow it down. Which axis? The 0, the 90, the 180, or the 270?
Wait, what? Oh, where is it? It's on 180, right?
That's correct, because this is -1, 0. x is -1, and we know for our axes that r is 1 on all 4 of our axes. So we're done. X over r would be -1/1. So our final answer is, give it to me.
It is, hold up, 3 pi over 4.
Careful. When you say
Oh, no, wait.
4, you're giving
No, what?
45-degree reference angle, but I don't want one that's in the middle. I want the axis.
I'm confused. 4 pi over 4.
4
Right?
pi over 4 is correct, but what does that simplify to?
Just pi?
That's right. There it is, right here. Right?
Yes.
Pi.
Yes.
So 180 degrees, but since we're doing it in radians, our answer is pi. Good. So let's look at number 7 really quick. Let's label it real quick, okay? Tangent formula, what is it? Y over x. Okay, I'm gonna say something that I mentioned in the video, but Maverick, you didn't see it, so think with me.
Okay.
Normally, when I look at something with a 1/1, I'm thinking, okay, this is an axis angle. Why is this different? This is actually a triangle. How do I know?
Are you waiting? Oh, it's because every time you like move a lot, like the thing freezes because I'm doing this on my phone
Oh,
and then I can't hear you.
just assume that I'm talking to you for now, for the next like 2.
Okay.
So how do I know this is actually a triangle, not an axis angle?
Oh, because it's neither one of them is R.
Woo! Yes, yes, exactly. So this is not necessarily an axis. It's actually a triangle. What triangle has sides of 1 and 1?
I don't know. And what's it called? A
45,
right triangle?
specifically a 45, 45, 90 right triangle.
Oh, yeah, I wasn't thinking that.
Yes. So it has and I'm putting you on the spot a lot here, so you know, I give you also a lot
Yeah.
for, you know, answering these questions. But yeah, 45, 45, 90. And remember, the negative can migrate. So it could be up there with the y. So if y is negative and x is positive, I'll be here. That's a negative y, a positive x. But the negative doesn't have to be up there. It can move down here too, because it could be with the x. So we can also have an answer in that quadrant, -1 x, +1y. And I'll let you finish that later. We're pretty much done, but I'll let you finish it later. Or on your own. Guys, let's do number 8. Come back. Okay. Tazi and Miss Nyoko, did you guys try number 8 while we were chatting?
Yeah.
Yeah.
So what did we get so far? Just guide me.
So you label, right?
R over
Y.
y, the negative is going to be with the
-1.
negative on the y, yes. It's going to be negative in quadrants.
And quadrants in the bottom, right?
Wait, I'm jumping the gun a little bit. I'm sorry. Is this a triangle or an axis angle?
Triangle.
Triangle? What kind of triangle?
30, 60, 90.
Woo, 30, 60, 90. Girl knows her triangles. 1, radical 3, 2. So we're going to be here, -y, and here, -y. Let's label.
I love you.
My R is 2. And so since we know this is a 30, 60, 90, I can go ahead and label the x values as well. Negative radical 3, positive radical 3. But at the end of the day, I really care about this right here. So across from the 1, we would put what?
30.
30, 30. Both are going to be the same.
30.
So Miss
The
Patty,
angle is-
can you tell me my first answer? We'll call it theta 1. What's the first angle? It's not 30.
Is 180 plus 30, which is 150.
Careful.
8, my bad, which is 225.
Careful, you're adding zeros in the ones place.
Two.
So it should be,
guessing this. Hold on.
okay, take your time. And then Miss Ariola, give me the second angle.
On the second angle. To the first one is 210.
210, do we agree?
Yeah.
Yeah.
And then the second answer is gonna be?
Don't you have 360?
That's right.
And
360.
it's 390.
But careful, because when you go around here, you don't actually go a full circle. You stop early.
So you subtract.
So subtract, and that'll give me 330 degrees. We're so close. We're so close. Maverick, remember how our reference angle was 30 degrees? Maverick, I'm highlighting this. Okay, so our reference angle was 30 degrees, meaning our answers, when we go to radians, will be pi over 6s. Now we just need to figure out how many pi over 6s, how many 30s. So 30 times what gives me 210?
7.
7, so that's gonna be a 7 pi over 6. Even from yourselves. Same deal. 30 times what gives me 330? Answer?
11.
11. So this is 11 pi over 6, and you guys are done. We did number 8. Okay. So I'm going to, I think, do the harder problems. So let's do 10 and 11, and I'll let you guys do 9 in a second, okay? All right. So let's do number 10 together. What should our first step be? There's actually a lot going on here.
Isn't where you factor?
If I factor, so here are the factoring methods that we have. GCF and difference of squares. These unfortunately don't have anything in common, so I can't do a GCF. And it's not a minus sign, so we can't do difference of squares. So we don't need to factor, but we can still solve the problem. Think back to 2 weeks ago. What did we do when we had all this extra stuff around our tangent? Anyone? How can I get rid of them? Specifically by, I'll subtract the radical 3. I want to move it to the other side. So what we want to do here, make a note, is we want to isolate our trig expression. In this case, we want to isolate tangent x. That way we can make it into a problem that looks like these, where it was like all by itself, right? Tangent was all by itself. So we just want to move all the numbers to the other side. So let's do that. I'm moving the radical 3, so I now have 3 tan x equals negative radical 3. Next step, what should I do?
Divide. No.
Correct.
Divide.
Divide. Because I want to get rid of that 3 that's being multiplied. So now we have tangent x equals negative radical 3 over 3. And I'm going to stop right there. This doesn't look like any triangle that I am aware of. I've never seen a triangle with a side length of 3. So before we go and say no solution, I want to challenge you. This is a tricky question, okay? I'm letting you know it's a tricky question. So do me a favor, circle this and make a note. We're going to rewrite it. That's not a triangle that we know how to deal with. It just isn't a special triangle. So we'll rewrite it. So look here off to the side with me for a second. In the past, okay, say yes if you can hear me.
Yes.
Okay, I have one person. Tazi, are you there?
I was muted.
Okay,
Yeah, you can hear me?
because I want to make sure that you're hearing this part. In the past, when we would get an answer like 1 over radical 2, do you remember that we would rationalize it by multiplying top and bottom by the same thing?
Yep.
So my final answer would be radical 2 over 2.
Yep.
Okay. This looks really similar to that. My answer here is negative radical 3 over 3. My question to you is, what do you think this number started as before it was rationalized?
1 over radical 3.
That's exactly it. 1 over radical 3. But a negative 1 over radical 3, right?
Oh,
Yes.
So this started as negative 1 over radical 3, but we need to check, okay? Let's do a quick check. I would multiply top and bottom by root 3, and indeed, I would get negative radical 3 over 3, so they're the same. So we're going to rewrite this as negative 1 over radical 3. That's the key step. I'm going to erase this stuff, give myself some room, and let's go from there. Guys, finish the problem from here. I'll give you a minute or 2 minutes. Ask me questions if you have them. But from here, it should be, the steps are the same. There's nothing tricky about it. Label your X and your Y and go from there. Well, let's take 1 minute to finish this problem.
yes, I have a question.
Yeah,
Okay, so you know tangent, isn't it y over x, right?
right.
But what if the x is radical 3? Is that still correct, or does radical 3 always have to be r?
Or does the radical 3 what?
Does the radical 3 always have to be with r, or it could be with x?
So actually, let's look at our triangles really fast. 3069 is 1 radical 3, 2. And then 45, 45, 90 is 1, 1 radical 2. So the radical 3 belongs with one of the legs. It's not an r at all.
Okay,
Were you thinking of radical 2?
probably, yeah.
We're
Yeah.
still on 10.
We're
Yeah.
on number 10. Yeah. Have you finished yet?
Kind of, I think.
Okay.
I got radical 3 on the x thingy, x-axis.
Question, which quadrant did you draw your
Is that 4? I think 4.
quadrant 4? Do you guys agree?
Yeah.
Yeah, negative 1 on the y, positive radical 3 on the x. Where else?
And the 2
And
2 on the r.
and quadrant, yeah, and 2 on the r. And what's the other quadrant where I could have also drawn this figure? Or is that it?
That's the. I think that's it. I don't know.
on quadrant 2.
Y quadrant 2, you're right.
Oh,
Oh yeah.
¿Por qué?
because it's an x.
Flip the r. No, the x and the y.
Yeah, because the negative could be down there with the x. It could move. It could be on the top or the bottom. If there's an r, then the negative has to be with the other guy. But when it's y and x, when it's tangent, that negative can go up and down. So it could be negative radical 3 here, positive 1. Why not? So let's finalize our answers. These are both 30-degree reference angles because they're across the 1. So Maverick, what's our first answer going to be? Give me this angle here. So it looks like it's
That's
30
what 3 pi over 4.
3 pi over 4. Okay, I want to caution you about that because you're remembering the placement, which I just told you. I want to caution you about that because look at my board. 3 pi over 4. When it says pi over 4, that means it's a 45-degree reference angle. That's only if it's 45 degree there.
So this one is pi over 6.
So yeah, give it to me first in degrees, and then we'll convert to radians.
I am confused.
Okay. What math should we do to figure out this big angle here, from here to here?
Add.
Oh, that's 150.
That's, yeah, 180 minus 30, that's 150. Let's leave it at that. What's the second answer, Ms. Ariola?
330
330, correct. You did 360
minus 30.
minus 30 for 330. Awesome. Those are our angles in degrees. We got to go to radians. Now, somebody earlier said pi over 6. Who said that?
Me.
Okay, tell me what's your first answer going to be, because it's something pi over 6. What's that something? Louder.
5.
What'd you say?
5.
5 pi over 6, correct. 5 times 30, which is 150. What's our second answer going to be?
11.
11 pi over 6, because that's 11 times 30, which is 330. We did it. Good job, guys. That was the hardest problem up until now. Okay, I'm going to do 11 with you because it's tricky. Ready? By the way, any questions before we move on? Are we good to go?
I think we're good.
Okay, let's do 11.
Wait.
I'll go for it.
There.
You good?
Yes.
Okay, we're going to do 11. So first thing I want to do is get sine by itself. Give me some ideas.
Subtract the, oh wait, where we at? Oh yeah, subtract the 1, add the 1.
Add the 1, let's do that. Good idea. So I have 2 sine squared x equals 1. What should we do next?
Divide.
Divide by 2, so I get sine squared x equals 1/2. Good, what should I do next? What do we still need to get rid of?
The square.
The squared. How do we undo a square? We take the square
Root.
root. That's right. Let's take the square root on both sides. And on the left side, show that it's canceling out your square. And at this point, I want you to make a note to yourself, draw a skull, like danger, caution. Oh my God. When you take square roots on both sides of an equal sign, do you guys remember what we have to add? Make sure you use a plus or minus, okay? So when we take square roots on both sides, the side that still has a square root will get a plus or minus. So our new step is sine x equals plus or minus radical. Let's actually break this up. Guys, what's the square root of 1?
1.
And then the square root of 2, we can just leave it like that. Ooh! Guys, what kind of triangle does this look like?
A 30, 60, 90.
Hold it.
Oh wait, no, 45, 45, 90.
45, 45, 90. What told you it's a 45, 45, 90?
The square root 2.
The square root 2. So this is going to be a 45, 45, 90 triangle. Now you're wondering, but miss, what is this plus or minus going to do for us? So let me explain. Okay, I'm moving our warning off to the side. Okay, so what we have here is our first complex trig equation. We have, I want you to write this with me on the side, sine x equals positive 1/2, or rather positive 1 over radical 2, and sine x equals negative 1 over radical 2. So we have 2 equations that we have to solve simultaneously. Don't worry, it's easier than it looks. Let's do the first one. Sine, Miss Nyoko, formula?
Sine is y over r.
Y over r, and it's positive r, so it's a positive y. Okay, you guys, where are our y values positive? Quadrants?
The quadrant 1 and 2.
1, 2. Boom, let's label them. My y is positive 1 on both. My r is radical 2 on both. And our reference angle will be what on both?
45.
45 and 45. Maverick, are you with us?
Yeah.
Okay, let's do the second one now, but we're not even going to say the answers yet, okay? Let's just move on to the second one.
Yeah.
This time, we're also have a y over r, but this time y is negative. So we're in quadrants
3 and 4.
3 and 4. Negative 1 on the y, negative 1 on the y, radical 2 on the r, just based on what this is saying right here. And so my reference angle again is what?
45.
45 and 45. Okay, guys, we're going to finish right now. What's our first answer? This angle.
Isn't it 45?
Correct. And in radians?
Pi over 4.
Pi over 4. Kazi, what's my second answer?
That's the plus 180. That's minus 180.
180 minus 45 gives you 135. Maverick, this is your favorite angle. What's our
Which
45
one?
degree reference angle? This one right here. Our 45 degree reference angle in quadrant quadrant 2.
3 pi over 4.
That's right, 3 pi over 4. How did you know it was 3 pi over 4?
Because I said it like 5 times.
Yeah, because you said it. And also because remember, 45 is our pi over 4. Tazzy, do you remember the pattern? Here we have 1 pi over 4. We just found 3 pi over 4. What are our last two answers from the right side?
5 and 7, right?
5 pi over 4 and 7 pi over 4. Guys, we did it. So this is the first problem that had 4 answers, okay? Because the question was, where's sine equal to positive and negative 1 over radical 2? So we had multiple answers. All right, you guys. Number 12. Let's do it. Actually, we have 5 minutes left, so I'll show you how to do this one. This question had said factor. So let's take some quick notes. When we factor, we will always check first if we have a GCF, the greatest common factor. So observe, do we have anything that we can factor out from both of these terms?
Yes, 10x.
Tangent, good.
And then we
So that's our
have
GCF. Since there's 2 terms here, make sure your parentheses has 2 spaces. Okay, tangent times what would give me tan x sine x? What are we missing?
sine x plus 1.
Sine x. And then she's moving ahead. She says this guy's just going to be plus 1. And let's check. If I were to distribute, that would give me tan x sine x. And if I distribute that, it would just give me, whoops. Yeah, that would give me tangent x sine x plus tangent x. And we're done. We factored it. So this right here is our factored expression, GCF.
Yeah.
Let's do a problem from the tough ones. Which one do you want to do? 15, 17, or 19?
19.
All right, let's do 19, because why not? Okay, Maverick.
Yeah.
Close attention, because I am skipping one of the parts of the lesson.
Okay.
Okay. So check it out. We have this crazy looking function. We're supposed to somehow solve for this, but notice that a sine is being squared here, and here it's not being squared. This vaguely should remind you of a quadratic. You see the connection?
Yeah.
It's something that's being squared plus 2 times that something minus 3. So this really, I want you to make a note. This is a quadratic, and we need to factor it. So what we're going to do is, in one step, clean this up a little bit, right? Do we want to let monkey? Did I use monkey?
Yeah.
Okay, let monkey equal sine x. So instead of sine squared x, instead we're going to write
And
monkey squared
plus 2n
plus 2 monkey, keep going,
minus 3 equals 0.
minus 3 equals 0. Maverick, did you catch the trick that we did there? We just replaced everything that's
Mm,
with an m instead. So we have monkey squared instead of sine squared, plus 2 monkey instead of 2 sine, minus.
yes.
Now we can factor this. This looks so much easier. I need 2 numbers that multiply to what?
2, 4, no.
So multiply the outsides. I need 2 numbers that multiply to 1 times negative 3. Negative 3. And they have to add to what number?
To
Numbers are?
Add
it's
to 2.
They have to multiply to negative 3, but add to 2. What are the only numbers that multiply to 3?
3 and negative
3
1.
and 1.
3 and negative 1. Nice. Okay, let's do it. So our first term, stick with me, is m plus 3. And our second term is m minus 1 from 0. Now remember, we made up monkey. It doesn't exist. So let's replace it now. Instead of m plus 3, what are we writing?
Sin x plus 3.
And on the right side,
Sin x minus 1.
equals?
0.
Beautiful. Now we factored. What do we do once we're done factoring? Set each term equal to?
0.
0. So on the left, let's do this. Sin x plus 3 equals 0. And on the right, I have sin x minus 1 equals 0. Okay, draw a line down the middle. We'll do the left side first. So this is the second problem today that involves a more complex breaking up into 2 different equations. Let's do the left side. Okay. What should we do first to solve this?
Subtract the 3.
Minus the 3. Okay, discuss amongst yourselves. What the hell are we gonna do?
You put it,
I heard you say something, Tabby.
you put it over 1.
Put it over 1,
And then that's y over r, but
and then y over r.
I don't think the side could be longer than the hypotenuse.
Can you speak louder?
The side can't be longer than the hypotenuse.
Do you guys see what she's saying?
Yeah.
So what are we gonna do about this?
It's no solution.
That's right. This is no solution. And if we were to explain Maverick, what would our explanation be?
Wait, what? I'm sorry.
Why is this no solution? Hint, look at your y and your r.
Because the R is 1. The R is smaller when it should be bigger.
That's right. The hypotenuse is shorter than the leg. This is impossible. Answer, no solution. So good. We're done with that side. Let's do the right side. Give yourselves 30 seconds, I would say, and then let's check in.
Solution as well.
So Miss Nyoko, what's your first step?
So I subtracted, so I added the 1 to the side, so it would be, then I divided by 1, and then I named it y over r,
Beautiful.
but you can have the same angle, because r has to be bigger.
So what's going on here?
They're the same angle, they're the same length.
So does that mean we have no solution?
Yeah, right?
No, it's a point. It's a
Which
point.
one? What kind of angle is this?
What's that?
Oh, it's a axis thingy.
There you go. There you go. So R can be 1 and Y can be 1, but only in one spot. Where does that happen?
What degree is this? 90?
Hint, I need Y to be positive 1.
90 degrees?
That's at 90 degrees. 0, 1. Let's label it. Everybody see that? That's the only place where I could get a positive 1 for y over r. Because if I went down, that would be negative 1 over 1, which is the wrong sign. So final answer, x equals 90 degrees is correct, but we want it in radians. So final answer is pi over 2. And that was the only answer for number 19 because the other guy gave us no solution. Hey guys, good job. High five.
Was that it?
That's it. So your job, basically we did all of the work from the first section.
Okay.
Ooh.
I think I told you to do 2, right? And then you just have to do one more problem from these more complex ones, because I did 2.
So just one?
You just need to do one more.
Okay. Okay.
All right. Do you guys want to stick on and do it and check your answers with each other, or do you want me to end the meeting? I'm fine with either.
Well, I'm gonna leave this so that I can understand it now.
Yeah, I got it, miss.
Bye, everyone.
Bye, man.
Goodbye.
Thank you.
Bye.
Thanks for coming.